Hey, what's up guys? It's me, Sakani again, here to help you guys out with another video. And this time we're going to talk about Big O notation. And this has nothing to do with the Japanese anime Big O. If you know about it, it's just a funny joke. But let's get serious. Big O notation. Big O notation, as I said, is the order of magnitude for which it is the notation that expresses a computing time, or the complexity, as a term in a function that increases most rapidly to the size of the problem. Now, with that huge definition, basically Big O notation specifically describes the worst case scenario and can be used to describe the execution time required or space used on your memory or disk by an algorithm. So, the first one you have is order operation 1, which is dealing with bounded time. Now, that is constant. It stays constant, and it stays at 1, obviously. So it's constant time also if you want to remember it. You have order operation n, which is linear time. And with these numbers I've written is by times a certain function by 2. So order operation n is linear time. So I have it as 1, and you'll just multiply it by 2. So you have 1, 2, 4, 8, 16, 32, 64, 128, and 256. Now, order operation log 2n. This is a lot of math, of course, but order operation log 2n is logarithmic time. You have to remember the times that they are, so please note that. It is logarithmic time. Now, order log 2n is really easier because it's by 1, really. It's not constant time, but it's easier to be done, so it wouldn't be the easiest of the times, I'll say that, but with this, it goes order by 1, 2, 3, 4, 5, 6, 7, and 8, and so on. So it's by 1 each time. It's not like order operation 1, which is constant. It stays at 1. It doesn't go past that. It's just 1. So n log 2 is basically n log 2 time. There's no other word to use for it, but it's n log 2 time. And n log 2 time is just, if you want to read these numbers, you can kind of read this. I know it's kind of hard, but it's 1, 2, 8, 24, 64, 160, 384, 896, and 2048. If these are basically, I'm going to use this as the rates of growth. I'll use that. But then you have quadratic time, which is order operation n squared, which is really large. It is pretty big. So it was 1, 4, 16, 64, 256, 1024, 4096, 16,384, and then 65,536. A lot of numbers. So quadratic time is almost the largest one. Cubic time and exponential time I'm not going to get into because they're really large numbers, like to the point that with cubic time you'll get to 2 million. And with exponential time, you're getting to the size of the universe in a nanosecond. But these are basically the order operations in this context of math. Now with computer science, if you wanted to do it, I'll do one example. It's easy. For bounded time, you can do a Boolean variable. So if you do I don't have a lot of room, but bool, you do bool, you do like an is first element, and that was really hard to see, is first element, and then do unnecessary information, but basically you do a Boolean variable where you have the bracket, then you have an if string. From that if string, you have the 0 to null function, and you return if it's true. So, and then you return it false. And many of the other assignments, well, not assignments, but the other times we'll use a Boolean variable, which is a lot easier to use. So you use a Boolean variable for most of these, and you'll do an if string or for statement. So basically, this is Big O notation. I hope I helped you understand it. It's really large, a lot of numbers, but hope I helped you guys understand it. Use references and use this video. So, of course, study hard, and I hope this video helped you guys out.